In today's Capit Explains, we're going to be looking at Section 3, question number 14 from our Big Blue Book. You can find this question on page number 1232 of your Big Blue Book. Let's read it together. If 3x minus y equals 12, what is the value of 8 to the power of x divided by 2 to the power of y? Now, this is a tricky looking question. It deals with a popular algebra topic called exponents, and we want to be pretty solid with dealing with exponents. We start with what the question's asking us for. 8 to the power of x divided by 2 to the power of y. Now you might be jumping to think, how can I divide these two numbers? But be careful. I'll show you what you can't do. You can't divide 8 and 2 and just get this to be magically 4. In fact, the reason that's wrong is because we're missing something really important in this initial setup. In order to multiply or divide exponents, you need something called a common base. We don't have that common base right now. So let's see if we can get it. When we're dealing with common bases, I like to pick with the smaller of the two numbers I'm getting. So let's make this a common base of 2. 2 on the top, 2 on the bottom. Now let's think for a second. I can't just randomly turn this into a 2. What do I have to do to the number 8 to make it into 2? Since we're dealing with exponents, let's think of what power we'd raise 2 to make it become 8. 2 to the third power is exactly the same thing as 8. So 8 to the power of x is the same as 2 to the third to the power of x. And our bottom can stay the same, 2 to the power of y. Okay, now we can execute our exponent rules in ways that we're a little more comfortable. Remember, when I raise an exponent to an exponent, no matter what those two things are, I'm always going to multiply. So this becomes 2 to the 3 times x, 2 to the 3x. Divided by 2 to the y still. Now we can put our division rules into effect once again. When we divide exponents, we want to keep the common base and subtract our two exponents. 3x minus y. It doesn't matter what these two are, even though they're both variables and I can't actually combine them, I can still subtract them and leave them as is. The reason that I'm so happy to do this is because I see right up on the top that it gave me 3x minus y equals 12. That's no coincidence, as you might imagine. It wanted me to get to this exact right spot. So 2 to the 3x minus y is going to be equal to 2 to the power of 12, and look at that. That's choice A right there for me. This is a really good exponent question. It illustrates a couple of the basic exponent rules that you guys should have down, how to multiply and how to divide, but it also illustrates what we do when we have a strange, non-common base like this. If you want to find more of these questions, you can hunt them down in your Big Blue Book and follow these instructions on how to tackle them. Good luck, everyone.